So, Kevin, thanks very much for that. First, I'd like to acknowledge my co-authors there, Michael Dillon, Jesco, Lawrence, and Pat Toohey, so very much. So, just as an introduction, I acknowledge there's a lot of things coming at farmers currently, but I firmly believe that water quality is one of the issues we cannot ignore. Water quality is really important for the agri-food industry and improvements in water quality. And it's really important from your business of operating your dairy farm, but also from the processing point of view. And it's also really important from a marketing point of view. High quality, milk and dairy products come from an environment that is high quality, will be an important marketing ply going forward. It's also important for the community you live in. And you live in a community where drinking water is important, where tourism is important, where amenity is really important. So, water quality is a core requirement. Acknowledging, and this is not about the derogation, but acknowledging that the derogation is really important and the retain of the derogation. However, improvements in water quality will be required in material whether we can retain or not retain, and that is throughout Europe. So, water quality is important. Saying that, improvement in water quality will be important in terms of our case we can make to the Commission in terms of retaining the derogation. No doubt about that. No doubt about that. So that as an introduction, just my outline then is the role of agriculture in improving water quality. I want to talk about recent trends in water quality, then look at river catchment, ecological status and nitrogen reduction targets, and recent trends in fertiliser use and soil fertility. I want to just particularly, given that I was in Munster, I just said we focus on the Blackwater catchment, because I think water quality has to be approached in the catchment level, so that's why I like to do that. And then at farm level, how do we go to improve water quality? And I hope at the end of my talk, and Kevin talked about it at the very start, I hope at the end of my talk I can convince you that we can improve water quality at farm level. But And I'll show at the end, it does require practice change. And we'd be foolish not to think that it doesn't require practice change. But all that's possible. So, first of all, I just talk about pressures in influencing. And there's a lot of talk out about the pressures influencing water quality. First of all, the water framework is there as our regulator in terms of water quality, and that has set a target that all water qualities will be of good ecological status by 2027. The main pressures then affecting water quality are agriculture, and that's not surprising given that we're by far the massive use of agricultural land, hydromorphology, urban wastewater and forestry. Agriculture is significant, and if you look at the EPA data, if you look at the water bodies that are at risk, there's about 1,600 of them, and about 1,000 of those, the prime pressure on those is agriculture. But saying that, 2/3 of those that are of those 1,000 water bodies have also other significant pressures, whether they are urban wastewater or hydromorphology. So that's really important, and we don't shy away. But if we look at the last EPA report, which was the report from 2016 to 2021, 54% of Irish water bodies were of good or high ecological status. The EPA run a report every 3 years, so next year we'll have the report for 22, 23 and 24. So it'll be very interesting to see what comes to that. Do we see increases in water quality in this new report? I would suspect, and my premise is that we probably will, but we have to wait and see. So, again, this is for information purposes. We talk about ecological status, and that's how the EPA measure whether they're good or bad water quality. And I just wanted to talk about then what is ecological status. And it refers to all surface waters, whether they're rivers, lakes, estuaries or coastal waters. And it's three components. There's the biology, they look at the water quality, and generally the EPA look at 1/3 of our water bodies every 3 years. So that's why they're reporting after the 3-year period. They look at the biology, and that is looking at the ecosystem in that water in terms of. And they would look for identifications of, looking at the ecosystem is, what is indication of that is that water body, is it impacted by pollution or not? And they can tell from that. And as I said, that's done in a 3-year roll. They also consider the water quality in that catchment, and that's measured by the phosphorus level, the nitrogen level, the ammonia level, and any chemicals residue, and the hydromorphology. And listen, just the hydromorphology is just the flow of the river. And it's really not affected by agriculture, but it's what disturbs the flowing of the river. And that affects the ecosystem in the river. And whether that is weirs, or whether the dams, whether it's the dredging rivers and that. And they all can, and the bankment and along that river course. So that's just it. The other thing is, then they classify them high, good, moderate, poor, or bad. And it's the one that's the lowest dictating. So if you look at, say, water quality is poor, that water body is considered poor. So it's the lowest one. So you need to be good in all those three in order to get good water quality. I thought that was important because that's the measurement that the EPA use. So then if we look at it, and then just to look at then phosphorus concentration, which is the two big dictators of the water quality in any water body, is about the phosphorus level and the nitrogen level. So if we look at the phosphorus concentration, and again, this is EPA data, and it's the average for 21 to 23. And looking at river water bodies, just river water bodies, 27% of the Irish river bodies had unsatisfactory phosphorus levels. That means that they were greater than the EU requirement of 0.035. So 27% of our river water bodies. And I show you the trends over the years there on the bottom. And the trends are if you would say that they're slightly reducing. I have the map of Ireland in and looking at and these are all monitoring points from the EPA. Blue says it's high, green it says is good. All the other colours are either moderate, poor, or bad. Red is bad. You can see from the phosphorus point of view that they're really scattered mostly around the country. They're not confined with, there's an area in the northeast, yes, you could say. There's an area in the south, mid-south. But, I mean, they are fairly well scattered around the country. So, phosphorus is really associated with heavy soils more than free-draining soils. It's associated with overland flow of soil connected to phosphorus into water, and there's where your connection is. If we look at the nitrate concentration, again, this is the average for 21 to 23, and it said that 42% of our rivers had nitrate concentrations greater than 1.8. 1.8 is the level that the EPA use for good water quality. So if it's greater than 1.8. So 42% of the rivers have greater. Again, I show you the trends below in terms of, and this is the average for the country, and you can see at best they're static. The map of Ireland then shows you the monitorings right throughout the country, again for nitrates, and you can see nitrates really is a southeast issue. It's not along the west of Ireland, really, or the west of the country. And nitrate is a problem in free-draining soils, where nitrate is directly leached down through the soil. It's connected with free-draining soils. So, I think it's important to think. The other aspect that really affects water quality is our trends in terms of fertilizer sales and use. And this graph shows you the fertilizer trends in sales for nitrogen, phosphorus, potash, and lime, and comparing 2018 to 2023. And you can see that nitrogen sales nationally, total sales, have reduced by 31%. Phosphorus is 34% reduced, potash 23%, and lime is roughly based on last year's, is similar back to 2018. If you look at the National Farm Survey data then, where they measure it on different farms, on farms application rates, and again, I'm using 2020 data for this, the base data versus last year, 2023. And you can see that on farms, nitrogen, phosphorus, and potash has reduced. Nitrogen is reduced on average by 21% or 16.5 kilos. That's on all farms in Ireland. And phosphorus is reduced by 23% or 2.3 kilos, and so on. On dairy farms then, what has happened on dairy farms? And I just pulled out dairy farms on their own, and you look at nitrogen has reduced by 19%. But given that we're using higher levels of nitrogen on dairy farms, in dairy farms it has reduced by 34.7 kilos. So slightly less than the average in the country, but in terms of quantity it's much more. It's twice the level on the average. And again, phosphorus levels have reduced by 3.8 kilos, and I'll come back to the importance of those later on. And potash levels has reduced by 9.3 kilos. So that's from a national point of view. The other thing to consider then is, where are we going in terms of soil fertility? What I'm here is summarizing the analysis of samples that came through the laboratories in terms of soil analysis for 2023. And I have it broken down in the proportions of soil samples that were in soil index 1, 2, 3, and 4. And if you look at it, I think it's about 43% of soils were deficient in either soil index 1 or soil index 2 in P. Roughly around 28% were adequate, and 29% were soil index 4, which is, you would say, is in excess. If you look at potash, the balance is probably better. And if you look at lime, 48% of the samples coming through the laboratory were deficient in lime, and I'm using 6.2 pH as a deficient. So what can we say about that? And the debate then is the reduced fertilizer. I mean, is it going to be a serious issue? Increasing, I mean, again, I'm going back to Johnstown data in terms of where they have worked on the effect of, say, lime. Lime is a no-brainer in terms of farm. Increasing lime has been shown, and I'm talking about increasing it greater than 6.2, can increase the soil index, the P soil index of your soil. And it can also increase the efficiency of the nitrogen. So having almost 50% of our soils deficient in lime, and it doesn't affect water quality. I mean, it's really a no-brainer that we need to get the pH right. In terms of P then, and you talked about the P, and I look at it nationally from a P balance point of view later on, but what I'm saying about P, and looking at the breakdown of the proportion that's in soil index 1, soil index 2, 3, and 4, it's saying that slurry, which is a valuable source of P, should be prioritized on the part of the farm that's deficient in P, and then supplemented with chemical P and K. I come back to the issue again, is the reduction in P that significant? And I don't think it's that significant if we manage the amount of P we have in our system properly. If we don't manage it, yes, it'll be a problem. So now I want to just go on briefly then talk about water catchments, right? And this is, I mean, if we look at nationally, again, this is taken off of catchment.ie from the EPA website. There's 46 catchments in the country. I've highlighted a number of catchments because these are the catchments that we have identified for the Better Farming for Water campaign. And you can see the justification for those, pick of those, if you go back and look at what I went through is the soil, the P, and the nitrogen areas of poor quality in terms of water. So we have identified 8 river catchments, starting in the Bandon, the Lee, the Blackwater, the Suir, the Nore, the Barrow, the Boyne, and the Slaney. And as I said, I'm going to particularly focus on the Blackwater for this part of the talk, because I'm firmly of the belief is that we have to approach the water quality on a catchment level rather than a country level or county level or that. It's really important. So, and again, I've identified the water bodies in, and when we talk about water bodies, the vast majority, being over 3,000 of the water bodies, of the 4,000 water bodies, are river water bodies. That's how they're measured. And you saw that in the map which I showed you. And that's about 66% of the water bodies. Lakes contribute to 17%, groundwater 11%. Transitional water, that is the link between the fresh water and the sea, is 4%, and coastal is 4%. I'm giving you a lot of this data because I think it's really important that you understand where we're coming from in terms of water quality. So, What I showed you here then is, again, the report using the ecological status coming from the EPA website in terms of the proportions of water in these 8 catchments, in terms of the proportion are high, good, moderate, poor, and bad. And I've summed the total at the end of high and good together, because that's what classifies whether the water quality is good or ecologically good or not. So high and good are brought together. So if you look at the Blackwater, 12% are high, 54% are good, 29% are moderate, 4% are poor, and 0 are bad. 6% of the water bodies are either good or are. So they're classified good in terms of ecological status. So on average, Blackwater is 66%. I showed you the average is 54%, so well above the average. The other feature of just looking at Blackwater is 29% are moderate. Very few are poor and very few are bad. So to shift the Blackwater to a good, well, it's not a very, very difficult thing to do. Now, some of the other catchments are more challenging. But the other aspect of the Blackwater, and you can see from the paper, is that Blackwater actually has deteriorated in quality in recent years, but it's still good in terms of national. But what I'd be saying is that based on those figures, putting some mitigations in place, it would be quite easy to shift back a much larger proportion of those water bodies in the Blackwater catchment to good. I'm not going to go down through all the details. If we jump down to the bottom of the line, the shore is there. Going to be much more challenging. You can see that 36% of those water bodies are a good ecological status. And you can see that 22% are poor. So the challenge here is going to be more. And if you could look back at the map, and again I showed you the map of the nitrate concentrations and the phosphorus concentration, there's more than a nitrate issue there if you go back to the map. I mean, there's a phosphorus issue in the shore as well. So, again, going back to the point of approaching it on a catchment, I think is really important. So I just want to talk about the catchment and what's available in terms of technology or maps or data they can use. And I'm using, again, the EPA have really good maps and really good data at the moment. So they have generated these maps, and this is for the Blackwater. And some people here don't know the Blackwater. Some people are very familiar with Blackwater. It rises over in the Kerry, Limerick, Cork border in Slieve Lucra, and it goes through Bantir. The two big towns it goes through is Mallow and Fermoy. Goes into Patrickswell, turns left, and down into Youghal and out into the sea. There's a lot of tributaries, big tributaries. I see the chairman here in front of me. The Bride is at a big tributary as part of the Blackwater. The Function goes around Fermoy, the Aubeg around Castleton Roach. So, I mean, but the purpose of this map is to show the potential impact from a phosphorus point of view. And the deeper the colour, the more it's prone. So it's showing that in the Blackwater catchment, it's the west of the country that's prone to phosphorus loss, not the east. It's a darker colour. They rank them 1, 2, 3, and these are potential areas for phosphorus loss. They're not saying they're losing it, but the map would be that if you were putting mitigations in, you would say, I'd use this map. Phosphorus is really important if you're developing a program in the west of the Blackwater catchment. It's not a big issue in the eastern parts of the catchment. The other one then we have to look at is nitrogen, and the story is totally different. And this is from nitrogen point of view. And what the EPA use in terms of defining those areas is it's a combination of two things. It's the site type and it's the stocking rate that's on those. So you look at the Blackwater again. It's all the east of the country that's prone to nitrogen losses. So, and the mitigations from nitrogen will be very different to the mitigations for P. So that's why this data is really important in developing a program for it. Okay. Just another map, and these are all maps. And each catchment is divided into sub-catchment. And what I've shown here is the land use. And it's shown the proportion that is cultivated. And people that would know the Blackwater catchment, probably it's a no-brainer, but It identifies, and you can see in the section, in the middle, there's up to 35% that's cultivated land. Again, if you're developing a mitigation, you say, right, and I talk about mitigation later on. These will be the mitigations that will be important for that area, where there's a high proportion of tillage in it. And that is the Castletown Roach, Doneraile area of it. And the other area that's, again, on the dark side, and you can see the percentage is down around Con and that. And again, these maps are really useful to say that, right, I want to put in a mitigation, and I talk about cover, green cover over the winter. You'll be targeting some of those sub-catchments to putting those mitigations in. So these maps are really useful, and the EPA have a really good of these maps. So, last two slides in the Blackwater. So I just, and in the paper that we looked at a number of monitoring sites, but the monitoring site here I'm referring to is Lismore Bridge. Lismore Bridge is really at the end of the Blackwater before it turns into, in at Cappoquin. And I didn't go any further because when you get into tidal waters after that, and this is fresh water I wanted to measure. So you look at it from the Blackwater point of view, and this is the nitrate, the P concentration at Lismore Bridge going back to 2007 and up to 2023. And I use the monitoring from the observation data set, and there is a number of measures per year, so it's not just based on one measurement, it's about 14 or 15 measurements per year on that. The really good story on that is that, and if you look at it, I have, the blue line is what's required for high quality water, the green line is setting what it is for good water quality, and the dotted line is the trend over time. So the trend over time is very positive. It's reducing phosphorus levels in the Lismore Bridge monitoring site has been reducing over that period. And you can see the last three measurements, 21, 22 and 23, are almost down to what can support high quality water, which is a really positive thing on it. However, if we look at nitrogen, the story is different. And this is the nitrogen concentrations. And as I said earlier in my talk, the EPA set a target of 1.8 milligrams per litre of nitrogen for good water quality, and that's the green line there. And you can see that the levels at Lismore are higher than that. I've also the 2.6, the yellow line, and that's the 2.6, the requirement for fresh water going into the estuary that the EPA set. So, what can we say about this? The levels are higher than we want, and there is no trend. If anything, is shown a slight increase in trend. So, what do you say? I mean, for the Blackwater, phosphorus levels are reducing. They're all going the right direction. Nitrogen, if anything, is slightly increasing. So, I mean, it's really the focus thing is about mitigation from nitrogen point of view in that, to move it up to the type of water quality we need. So, that's all probably the more theory, the data. So we talk into farmers then. What can farmers do about water quality? And I just want to talk about, first of all, I want to talk about nitrogen and phosphorus balance on dairy farms. So the phosphorus balance is really important, and this is what farmers do. And again, I'm using National Farm Survey data here to show the average balance of nitrogen on dairy farms using the National Farm Survey data. And you can see it. And that's the red line. The red line is the balance. So it was about plus 15 kilos back in 2018, and the last from the National Farm Survey Day is 8 kilos. So it has reduced. And the blue line shows the reduction in chemical nitrogen, and the orange line shows the reduction or increase, it could be the reduction or increase, that phosphorus is coming from concentrate. The blue line is showing phosphorus is coming from fertilizer. The orange line is showing phosphorus is coming from concentrate. Phosphorus doesn't come into farm just from the fertilizer. It also comes in with the feed. I suppose, looking at it, the blue line shows that phosphorus is reducing because I showed you already the fertilizer levels have reduced. But it's been compensated to some degree by higher concentrate and phosphorus coming in at phosphorus. So, I mean, using the mitigation for phosphorus, you have to consider what's coming in the feed as much as that. And if you're substituting phosphorus from concentrate for fertilizer, I mean, you're not going to go. You're not substituting totally there, because overall it is reducing. But it's a thing that needs to be worried. And the best example to this is what's happening in Northern Ireland. What I've showed you here is the average nitrogen concentration, the average phosphorus concentration across, again using the EPA data, from 2010 to 2023. That's the red line. The green above it is for good water quality, the blue below it is for high water quality. And we're shoving down to high quality. The trend above it is phosphorus concentration in river waters in Northern Ireland. And you can see how much higher they are than Southern Ireland. Now, there's a number of reasons for that. I mean, there's a system difference, there's a soil difference, and there's a farming difference. But even if you look at, and that's a real issue for Northern Ireland now, phosphorus in terms of water quality, and we've seen it all in the press in terms of the deterioration of water quality in Northern Ireland. And I didn't put it up here for the purpose to talk about Northern Ireland, but I put it up as a purpose that changing systems may end up with poorer water quality than you have at the moment. So what I'm really talking about is using mitigations in the system that you've developed rather than changing the system. And that's a lesson for everyone. I mean, the water quality resulting from those levels of phosphorus in water is a real serious issue. Okay, I'm told them time. All right. Nitrogen balance. And again, nitrogen balance, and again, you can use the National Farm Survey data. And again, the blue line here shows you, the red line shows you the balance in terms of, and there's going to be a big push out there as an advisory tool about using nitrogen balance as a key, and we're building it into AgNav in terms of a mitigation thing. But again, the story is good. I mean, if you go back to 2018, and we did everything wrong in 2018, with a nitrogen balance almost at 200 kilos, and today, last year, it was down to 140 kilos. So that means that's really important in terms of improving water. Again, I've shown the blue line. That's the nitrogen that's coming from fertilizer. The orange line shows you the nitrogen that's coming for feed. We can swap one for the other. So we need to watch. The system is really important. I'm going to get in trouble here. Okay, so, and I've a couple more messages, All right, you talk about nitrogen surplus then, and this is really interesting too, I think. This is Mike Dineen's work in terms of, he went out and over 2 years looked at the crude protein in grass on 28 commercial dairy farms, and all intensive dairy farms. And it shows the crude protein on the grass. Again, I'm talking about mitigation. And he shows you on the right-hand side the average crude protein in the grass for each of the months. And Michael would say a minimum of 16.5% crude protein in the grass. If we go above 18% crude protein in grass, then you're talking about more nitrogen has been leached. How that happens is that generally, if we look at nitrogen, the cow excretes about 50% in the feces, 50% in the urine. If you go to above 18%, a greater proportion goes to urine. Urine is much more prone to leaching, so it's an issue for you from a farming practice. So, and the other aspect of this is, fair enough, you can see that the crude protein in the grass is higher than your 18% in spring, but spring is not the major issue. Spring is an issue that you're going into the grazing season, you can use the nitrogen. But it's a real problem in the autumn, because growth is tailing off, and that is. So how you supplement your feed is really important in bringing down that and minimizing losses from the system. So, I'm nearly there, I think. So just take-home messages then about mitigation. The first one I want to talk about is increased storage. Our current legal requirement is 0.33 metre cube of slurry per cow per week. Probably some of you are aware of the study that we just completed for the first year on 100 dairy farms. That's old data. What is shown is actually the slurry requirement per cow per week is 0.41. It's 20% higher than that. So, we have a lack of slurry storage on farms. What's the advantage of increasing that slurry storage? I think there's real advantages. I mean, put the slurry out at the opening of the spring and putting all your slurry out under maybe. Soil conditions that are low temperature, waterlogged conditions, you're not using, you're wasting that slurry. So, increased slurry storage is really important in terms of maximizing your replacement value for your P&K. It reduces nutrient loss to water, it reduces nitrogen surpluses on farm, again, that way, by replacing chemical in on your farm. It's essential to be using low emission slurry. And I'm just talking about in the investment. There is an investment required, and we know that from the Minister launched his water and agriculture document during the summer, and they are talking about a 60% grant, sending a requirement to the Commission to OK from a grant point of view. So that's going to be really important. Point source, you're going to give out to me. Yeah. Point source, 2 more slides. Point source, I mean, again, if you look at the survey that Pat too, he said that there's 20 to 40 litres per cow per week getting into water tanks. We talk about having water tanks right. If we're getting 20 to 20 litres, that's what's getting into water tanks. We don't know what's flowing outside of water tanks either. So, point source is an issue on farms. We need to improve it. We're talking about gutters and downpipes being prepared. We talk about diverting clean water away from yards and concrete. We talk about restricting animal traffic on farms. And we talk about reducing the area of soil water. Dry stock farms, again, and I didn't emphasize at the start this, water quality is not just a dairy farm issue. It's all farm issue. And this is about dry stock farms. Again, if we go down again, slurry storage and point source is equally important. A lot of these are on low stock farms. They're in heavy soils. Therefore, sediment loss and peel loss is really important. Preventing access of livestock to streams is really important. Positioning riparian margins adjacent to water bodies in terms of minimizing the flow of P and K and sediment into water, and only looking at drains in the thing. Tillage farms. I don't know how many tillage farms are here, but they have a really important role. And this is summarising data again from a trial that was done in Oak Park, fair enough, in free draining sites. And they looked at what could overwinter green covers do for you. Summary of this is they compared a control where they just sprayed off it. They used natural regeneration by just harrowing or cultivating the soil, and they sowed mustard as a cover crop. Sum total, mustard was did significantly capture much more nitrogen than the regeneration. And if we look at the reduction in nitrogen losses, you got a 6% with the regeneration cover, but you got a 25% from the mustard crop. And if you look at the data they say on the literature, a lot of them are even higher than that in terms of reducing costs. So they have a very important role to play. What? Yeah. Okay, pigs, again, they all have a role, and that's really important in this, And again, I looked at it just for the Blackwater Catchment. 23 farms, there's about 19,000 sows. Fertilizer value, €32 per 1,000 gallons. Again, moving the use of pig slurry from autumn to spring is really critical, again, in terms of increasing efficiency of the slurry and reducing loss to the environment. Summary, water quality in Ireland is good in context, but there's significant opportunities for improvement. Actions alone, the actions required, and I've gone through slurry storage, point source, cover crops, increased use of organic manures. River catchment approach, I think it really has to be, and we were in New Zealand last January, and they're really successful in terms of intensive farming, advisory requirement, really important. Collaboration with existing water quality programs in terms of the Teagasc, farming for water EPA, as well as strong stakeholder engagement.